Good morning everyone. Today we are going to discussing about another important topic in computer network, which is HDLC. So in this session we are going discussing about this high level data link protocol, and at the same time we are going discussing about this PPP, which means point to point protocol. So in this session we are going to in depth of this how to design a HDLC frame structure and what is the importance of this HDLC frame structure and how to usage of this frame with help of this point to point protocols. So while coming to the session, so in the HDLC, so what is meant by HDLC? HDLC we calling as a high level data link control protocol. So when the name itself is available, we calling as a high level data link control. So in the previous sessions, we discussing about this data link control protocols. We discussing about this data link control protocols. In that one, we discussing about this multiple protocols we discuss. Like we discussing about this noisy protocol, as well as we discussing about this noiseless protocol. So in this one, we discussing about this stop and wait ARQ and stop and wait protocols, simplex protocol, as well as we discussing about this go back N protocol. So these protocols are very simple manner and easily we are implementing this kind of simple kind of protocol values only. But while we implement the communication network, this protocol is not suitable. With help of this protocol, we are not able to generate the high level network communication. So to overcome those kind of scenarios, we are going to using another kind of frame structure which we calling as a data link control. So in the data link control, we calling as a high level data link control. The previously also there is also a data link control, but they're using for simple communication. But this high level data link control is a group of communication protocols which we are using in the data link layer. So what in the data link layer? Data link layer is helpful to transmit the information from one end to another with help of this error free transmission. So if any error occur, so we are overcome those kind of errors in this data link layer. So in this structure, in this high level data link control, we are able to establishing one kind of network architecture. In this architecture, a multiple protocols we are implementing, which we calling as a group of protocols which we are implementing. So each and every protocol we sync up with this another protocol and we can able to generate a group of structured protocols that we calling as a data link communication protocols. Apparently we calling as a high level data link control. So in this one, in this data, we are going to organize in the frames. So in the previous protocols also, we are information transmitted in the form of frame structure only. But in this one, we are implementing in the organized structure frame packets only, frame format only. So these frames are transmitted through a network via destination to which verify it is successful receiving or not. So once we establishing one network architecture, so if any frames is transmitted, the frames are transmitted through this network communication, a group of protocols implemented, and that network communication, the information is transmitted from source to destination with successful transmission is there. So with successful transmission, which means high kind of efficiency is there and accuracy is very high. So which we get the a proper positive acknowledgement at this services values only. So if we take up as any connection oriented protocol, so which we applied, which is a point to point communication protocol, or else we calling as a multi-point communication protocols. So when you see this one, so when we discussing about previously, a normal response mode is there and a point to point communication response mode is there. So which means how we are able to balance that one. In this session we discussing about those parameters. So we discussing about this transfer mode. So while discussing about, we going to transfer information from one end to another end. So our HDLC parameter, our high level data link control, supports two types of transfer mode. One is normal mode and the other is asynchronous mode. What is normal response mode? Which means the normal response mode, when you see this one, here two things are there. One is a point to point communication mode. Apparently we calling as a PPP mode, a point to point communication mode. Another one we calling as a multi-point communication mode. So in the point to point communication mode, in the normal response mode, we having as a one source is there and one client is there. We calling as a point to point communication. One source point is there and another destination point is there. But in the multi-point communication, we have one source point is there and multiple clients are available, where two clients or more clients, if n number of clients also available. Based upon the network architecture we design, we can able to accommodate n number of clients. So while coming to this point to point communication, what is a point to point communication? One source connection is there as well as one client connection is there. Source is there as well as destination is there. The source is able to transmit the information from the source to the destination, from transmitter to the receiver, the secondary station, which means the client station or the receiver station, once the information successfully received, it can able to give the proper response to the server or source station. So here, what happened here? When we get the proper positive acknowledgement services, we are getting in this response values only. So here one-to-one communication is there. So proper connection establishment is there, and there is no deviation of signal leakage. There is no deviation of signal noise should be occurring in this session. So high successful rate come to this picture in the point-to-point communication. Similarly, when go for this multi-point communication, so we are going to establish one network architecture. So who are present in this network architecture? If you go for this 2 clients or number of clients present in this network architecture, the information is transmitted to the respective group of members, group of station, that we calling as a multi-point communication. One source is that n number of clients present in the network. But what is the network here? Who are present in the network? The people can able to receive the information. And next one is asynchronous balance mode. So we have 2 things are there. One is synchronous, another one is asynchronous. So in the synchronous, which we calling as a normal response mode, in the asynchronous, a group of members are there. So when the information is transmitted from source to destination, so what kind of command we transmitted, how the information is transmitted, and once we get the proper acknowledgement, whether go for a positive acknowledgement services or we get the negative acknowledgement services, based upon the response, the station also active. The station also align the next frame. For example, we have transmitted the 2 different frames from source to client. So the frame 1 is successfully transmitted. So we have to wait some random amount of time to get the response from the client. Once we get the proper response, whether go for this positive or negative, if we get the positive acknowledgement, we initiate the second frame. If we get the negative acknowledgement, we retransmit the first frame. So that kind of situation should be happen in the asynchronous balance mode. And when you see this one, in the HDLC frame structure, so in the previously frame structure, we having as a payload field is there, and we having as a header files, and we also having as a trailer files. But when you see this HDLC frame, which means calling as high level data link control frames, we having as flag address value. And apart from this one, we are able to get the address section value, which is we get the source address value and destination address value, to address value as well as from address value. And we are maintaining the control bit value. What is control here? We are maintaining the error control value as well as we have to consider the flow control value. For this controlling mechanism, we are using another important parameter, which is FCS. What is FCS? We calling as a frame check sequence. FCS in the sense frame check sequence. Why I am using frame check sequence? Because n number of frames are transmitted. We have transmitted the n number of frames we are transmitted from source to destination. So we are get the sequence manner. Whether frame 1 is successfully received, next one is frame 2 successfully received, similarly frame 3. So which means we are based upon this FCS mechanism, we assign in the frame should be in the sequence manner. So assume that one. So we are segmented into 10 different frames are there. We are going to transmit 10 different frames we are transmitted. So frame 1 is successfully transmitted. The frame 2 length is very high. So it receives, we take some random amount of delay time. Meanwhile, frame 3 is received. So end of the section, it should be arranged in the sequence manner. After the frame 1 received and frame 3 received, we have to wait random amount of time until we receive the frame 2. So we put it in the sequence manner. So frame 1 after receiving the frame 3, so frame 2 also received. But we arrange the proper manner in the synchronized manner, that we calling as a frame check sequence manner. So that is a major advantage of this HDLC frame structure. And so in the HDLC frame structure, we have n number of frames are there, types of frames are there, which we calling as a I frame, S frame and U frame. So I frame we calling as a user data type from the upper layer value. So this is similar to the previous mechanism, generalized HDLC frame structure values only, which we calling as a, but in this one, in the I we calling as information frame. So what are the information we grab from the upper layer, we are storing in this layer values only. And in the S frame and similarly U frame. In the S frame, we are default the upper information should be storage over here in this frame structure, and in the ending layer, in the end layer, we are inserting the flag bits values only. And similarly, U frame, which we depending upon the management information structure values only. So when the generalized HDLC frame, we having as flag bits, address fields, control, payload, frame check sequence. Same way, in this section also, we having as a flag, address, control, frame check sequence and flag byte. But based upon the frame structure value, whether go for this S frame, I frame and U frame, we having as a, in the payload section, we having as a receive data from the upper player, or the management information or storage information we stored in the payload section value. That is the difference of generalized frames to our HDLC frame structures. And how we are able to use the control section. So in the previously, we are going discussing about this control mechanism. So how we are able to use this control mechanism. So what is advantage of this control mechanism? So in the control section, we having as a 8 bits value is there, when 0, 1, 2, 3, 4, 5, 6 and 7. So this 8 bit information we have that one. So in the first bit should be 0. The first is always should be 0 value, and next one is based upon the sender value and receiver value, which is a number of sequence frames should be sent and the sequence should be expected. So when you see this one, n of s means number of frames should be sent, and here number of frames should be expected in the resource section. So and the next one is P and F. P in the sense pool value and F in the sense final bit value. So what kind of bit we received, whether it is a 0 bit value or 1 bit value. So that is the advantage. And similarly, when you see this one in the S frame structure and U frame structure, in the S frame structure, the carry floated, the carry coded control and error control information should be loaded based upon the 2-digit information, which is 1 and 0. In the previously I frame, we are going to using this only 1 bit, but in the S frame structure, we are going to using 2 bit, 1 and 0. So which means we are going to using the carry coded flow control value, which means error control information we are storing in this section. And similarly in the U frame, so which means identity frame, which means management information frame, which is the 1 value. That is the importance of this I frame, S frame and U frame. And next one is point-to-point protocol. So when we discussing about previously HDLC protocol, which means a group of protocols, there also we focused upon this point-to-point communication protocol. So what is meant by this point-to-point communication protocol? Because in the data link layer, we are going to use this multiple transmit protocol. We are using that one because one source is there, n number of clients are present. So to accommodate to all the clients, we are going to using this multi-point protocols. We are going to implementing this multi-point protocol. So data transmit between source to the client. So in which means one point to n number of point or point to point connections. So it is feasible to be having as a multi-protocol data between the two directly connected computers. And this is a byte oriented protocol, not a bit. It acting as a byte oriented protocol that widely used in this broadband communication to get the heavy speed of internet communication, heavy speed of data rate communication. And what kind of services we offered in the point-to-point protocol? So when go for this transfer rate, what is the formatting of frames we have that one, and how much amount of transfer rate is very high, because we are going to implementing this in the high level data link control, the high speed structure we are implementing. So the formatting of frames to data transfer rate also very high, and this should be the negotiation device should be established between these link values only, and encapsulation of this data link to the another data link frame structure, and authentication of devices. So who are authorized person can able to authenticate the devices, and the device data link between the one frame to another frame, which should be encapsulation of data in between the link frames. That is a major advantage of these services provided by the point-to-point. So in this session, we are going to analyzing about this. We are discussing about this. What is HDLC and what kind of frame structure we have that one. In this frame structure, what is the FCS mechanism we are using that one, and what is the control structure we are using that one with help of this I frame, S frame and U frame value, which is related to HDLC frame structure value. And apart from this one, while establishing this one, we are going to implementing this point-to-point protocol. How we are able to implement the point-to-point protocol to analyze the frame structure of my HDLC, that we discuss in this session. In the upcoming session, we are going discussing about this what is PPP frame format, which means while we establishing this HDLC frame structure, the framing structure should be much more different between the previous frame structure. So while accommodate and while designing those kind of frame structure, we are going to change our point-to-point protocol format structure. So that we discuss in the next session. Thank you.